All right, hey guys, how you guys doing? I'm just checking in with you guys, make sure you're doing well. So this is going to be the last lecture we're going to have for endocrine system. This is to wrap this up. This lecture again I gave before the break, so I want to make sure you're good there. So we've already been over this stuff already. This the hypothalamus pituitary lectures right before we were going for spring break. I gave this lecture, so I want to just do a real run through this really quickly, so make sure you're okay. Your review has been posted in the Google Classroom page. Make sure you do download that, print it out, and work on that. That's a great way to condense all the information you're going to need for your test. I'm going to post next week. Okay. If there's any questions, of course, reach out to me. Let me know. And we go from there. All right. So let's go ahead and get started here and dig into this lecture. So this is about the hypothalamus and pituitary gland. So last last chapter we talked about the diencephalon region of the brain. Okay, the diencephalon region of the brain has three major parts. That's the thalamus, the hypothalamus, and lastly the epithalamus. Okay, I remember I mentioned this. The thalamus we spend a lot of our time talking about. That was a major relay station, and the other two we're going to talk about more in this chapter because they play a role in the endocrine system. The big one is the hypothalamus here. Okay, so you guys already know hypo means below. Okay, so this gland is below the thalamus. So this is what it looks like. It's a beautiful picture of it, guys. Okay, you see here, this is the hypothalamus right in there. That little blue shading in you see. And that little walnut you see above it, that is your thalamus. That's your big relay station. And back behind the thalamus, you would have the epithalamus as well. Okay, and then just below the hypothalamus, you see the pituitary gland. We spent a lot of time discussing in this chapter. Okay, and also we have the anterior and the posterior pituitary as well. And we'll see there, and right there we see what's called the infundibulum. The infundibulum is the connection that will connect the hypothalamus to the posterior pituitary. Okay, so again, the hypothalamus is a part of the diencephalon region of the brain. And this is important. This is going to be one of your questions on your exam. This serves as the link between your nervous system and your endocrine system. This is the major link. There are other links too as well, but the major big link between the nervous system and endocrine system is going to be here in the hypothalamus. So, what does our nervous and endocrine system link up? In the hypothalamus. Okay, so its neurons produces and releases hormones when excited, which in turn will either stimulate or inhibit the anterior pituitary to release its hormones as well. Okay, its neurons also produce the two hormones of the posterior pituitary, and the hormones are stored in axons in the posterior pituitary. So this is a really important point because this question will be on your test. What hormones does the posterior pituitary make? And the answer is none. It doesn't make any. There are no hormones made in the posterior pituitary. It's a trick question. It's a question that a lot of students always miss. So the posterior pituitary does not make hormones. It stores them, doesn't make them. So the hypothalamus makes the two hormones of the posterior pituitary, and they're stored in the posterior pituitary. Really important difference. It seems like there's a major difference. They're made in the hypothalamus in two nuclei called the supraoptic nuclei and the paraventricular nuclei. They're made in those two nuclei, and then they move down the axons and they're stored in the axon terminals, which are in the posterior pituitary. Okay, and the hypothalamus serves to regulate when the master gland, the pituitary, releases its hormones. That's the function of the hypothalamus. The hypothalamus controls the master gland. We know the pituitary is the master gland because it controls almost all the other glands, but the hypothalamus will control it, but the release of inhibiting and releasing hormones. Also, in addition to this, it also regulates hunger, thirst, and body temperature as well. So here you go. Here's a beautiful image here. Usually, I'm sure they have access to this slideshow already. This is really important, and I'm going to have this image somewhere around you for your tests because this is really nice. This tells you the flow of how hormones are released. So if you see here, we have growth. First, we have this growth hormone releasing hormone. Growth hormone releasing hormone will stimulate the anterior pituitary to release growth hormone. Okay, then growth hormone will go to the liver, to bone, to and the muscle and other tissues to stimulate growth. But also, too, growth hormone is unique because it has two hormones that regulate it. It has a growth hormone releasing hormone, GHRH, and lastly, we have somatostatin, which is growth hormone inhibiting hormone. And growth hormone inhibiting hormone will prevent the release of growth hormone. Yeah, so they work together, kind of in tandem. So the only anterior pituitary hormone that has two hormones that regulate it is growth hormone. It's that important. So when we don't want growth hormone released, growth hormone inhibiting hormone is blocking it. Oh, and that's also called somatostatin. And I mentioned somatostatin before in the lecture over the pancreas. It's one of those hormones from the pancreas as well. Okay. Then we also have corticotropin releasing hormone, CRH. When CRH is released, it stimulates the production of ACTH from the anterior pituitary. Then ACTH will then go on to the adrenal cortex and stimulate the production of cortisol and aldosterone are the main two things it'll stimulate. Then we have thyroid releasing hormone, or TRH, will stimulate the production of TSH from the thyroid, from the anterior pituitary. Then TSH will then go on to the thyroid gland to stimulate the production of T3 and T4. Then we actually have an oddball here, and this is gonadotropin releasing hormone. And this one does some weird things. So we talked about how there's two hypothalamus hormones that regulate only one anterior pituitary hormone. Well, we have one hypothalamus hormone that does something really, really weird. It stimulates the production of two hormones from the anterior pituitary, and that's LH and FSH. And they go hand in hand. We remember LH stimulates the production of sex hormones, estrogen and progesterone in women, and testosterone in men. Okay, and then FSH stimulates the production of sperm in men and the release of eggs in women. Okay, so GHRH, when you release GHRH, you're going to get two hormones popping out, LH and FSH. Really important to understand that. And you see that right here, the far left column, the blue one, you'll see that right there. Okay, and then the last one is another oddball. So all these other hormones are releasing hormones. They stimulate the release of some anterior pituitary hormone. Dopamine, however, is odd because dopamine blocks the production of prolactin from the anterior pituitary. It inhibits it at all times. Okay, and this is because prolactin is governed by a positive feedback loop. So once prolactin is released, the mother's breast tissue will develop, get larger, and cause the production of milk for nursing. Once that loop starts, it don't shut off at all. It will not shut off. So dopamine blocks it from happening all the way. So that's why it's a little different. So dopamine only inhibits. There is a prolactin releasing factor. I'm not going to get into it. It's really weird how it works, so I'm not going to talk about it in this class. Okay, so move on to the anterior pituitary. You've already seen this stuff before. I'm going to go through it with you really quickly, though. So if you look here, the anterior pituitary is the one on your left. Okay, you'll see it here. It's on your left. Okay, we call this the master gland, or sometimes we also call it the vice president because of its wide-ranging controls and effects on other glands throughout the body. It's also called the adenohypophysis. And why do we call it the adenohypophysis? Okay, so hypophysis describes the pituitary. Adeno means it's true gland. Okay, so adeno means gland. You see the word adeno, that means gland. So the anterior pituitary is actually true gland. It came from it's based on where it developed from, and the anterior pituitary comes from oral glandular mucosa. It comes from basically from the upper roof of the mouth. So when you are about 21 days in your mother's womb, there's a little bud that broke off called Rackey's pouch, and the anterior pituitary grew upwards towards your brain. Also unique that the anterior pituitary is not physically connected to the hypothalamus. It's connected through what's called a portal system. It's a system of veins. Okay, so how does the hypothalamus stimulate the anterior pituitary is by what's called the hypophyseal portal system. This is a series of veins, basically, that where the hypothalamus will secrete its hormones into this portal system, and then those will be taken to the anterior pituitary, and then that will stimulate the release of the hormones in the anterior pituitary. Okay, and so it gives a system of veins as well. Okay, and then the mnemonic you want to know for remembering the hormones in the anterior pituitary is flat peg. If you know that, I guarantee this is going to save you a lot of time in studying. Flat peg. F is FSH, or follicle stimulating hormone. L is luteinizing hormone, or LH. A is ACTH, or adrenocorticotropin hormone. T is TSH, or thyroid stimulating hormone. P is prolactin. E is nothing. There's nothing there for E. And then G is lastly growth hormone, or GH. Okay, if you remember that mnemonic, I promise you, this will save you a lot of time studying for your over the anterior pituitary. Now, here's a video here if it wants to show up. I don't know if it will or not. Yeah, here we go. It's perfect. This is what it looks like, guys. So I want to show you what the anterior and posterior pituitary do. So if you see here, here's the diencephalon, and here's the stomoduum, which is basically the roof of the mouth, basically, guys, okay? So you see there's a growth upwards. That's called Rachi's stalk or Rachi's pouch that grows up from the mouth, okay? And then there's a growth downward from the diencephalon. That's going to be the posterior pituitary here, okay? So this is called the pars nervosa, okay? And then they thicken and thin, and they come together and stick together. There's also what's called the pars intermedia. That's where melanocyte stimulating hormone comes from. Okay, and then there you go. Here's your posterior lobe, here's your anterior lobe. This then will degenerate, and then there you go. There's your pituitary gland. There you go. And things can go wrong, and you have some abnormalities as well. So that happens. So we won't go into that, though. There it goes. All right, so there we go. So that takes care of the that's where your pituitary gland comes from. So let's move into the anterior pituitary real quickly. So we've already been over this but we have FSH, so flat peg mnemonic. So flat peg, FSH, LH, ACTH, TSH, prolactin, and growth hormone. So FSH stimulates the development of the follicle in the ovary and production of sperm in men. Luteinizing hormone separates the production and release of testosterone in men and estrogen in women. Thyroid stimulating hormone stimulates the production of T3 and T4 from the thyroid gland. So you see in your image here, follicle stimulating hormones over here is under the control of gonadotropin releasing hormone from the hypothalamus. Follicle stimulating hormone goes to the testes or ovaries, testosterone in men, estrogen in women. Luteinizing hormone is production of follicle stimulating hormone is production of sperm in men and estrogen sperm in men and the follicle in women. Okay, LH would be testosterone and estrogen. Then thyroid stimulating hormone will stimulate T3 and T4. What was that controlled by? TRH. Then we have prolactin, which stimulates the production of milk in the breast, and again, that's going to be controlled under the control of dopamine. That's going to block the release of that. Lastly, we have growth hormone, which is a little bit odd. We'll talk about that one really quickly. So growth hormone shrinks fat cells directly. So growth hormone actually is not the hormone that carries out all the effects of itself. So growth hormone actually stimulates another messenger to go do it for it. Okay. So what growth hormone does stimulate fat cells to give up their fat, basically. So it shrinks fat cells, essentially. Okay. However, GH does not have a lot of direct effects on the tissues. It stimulates another factor to do it. So it stimulates the liver to produce and release something called insulin-like growth factor, or IGF-1, which carries out most of the effects of GH. Okay. So all the effects will be carried out by that. by insulin growth factor. So make sure you do know that for your exam, that GH will stimulate the release and production of insulin-like growth factor. Okay, this is like growth factor, but then go on to do a lot of the effects that growth hormone would normally do. So IGF will stimulate muscle and bone to take up more amino acids. It stimulates the release of glycogen from the liver, and it stimulates growth throughout the body. So all of the actual growth effects of growth hormone are carried out by IGF. That's the one who does all the effects. So make sure you are aware of that. Okay. Then we have adrenocorticotropin hormone, or ACTH. It's actually two different hormones in one. It's a really weird hormone. That's a lot of different effects. Okay. So ACTH, once it's stimulated by CRH from the hypothalamus, once you get that stimulation from the hypothalamus, ACTH will then go to the adrenal cortex. Okay. And ACTH will stimulate the release of aldosterone from the zona glomerulosa. I mentioned this in the lecture over the different glands. The zona glomerulosa of the adrenal cortex produces aldosterone. Okay, and this will stimulate the retaining of sodium and the excretion of potassium, and this will raise the body's blood pressure in response. Okay, ACTH will also stimulate the release of cortisol, which is a stress hormone from the zona vesiculata. Okay, and this raises blood pressure, blood sugar, slows the immune system, causes tiredness, and slows digestion. So this is what we call the stress hormone. This is the stress hormone. So when you guys get stressed out in my class, whatever class or whatever you get stressed out in, this is caused by cortisol. Cortisol is the stress hormone. Okay, and so when you get stressed out, cortisol gets produced. It raises your blood pressure. It raises your blood sugar. It slows down. It also slows down your immune system. So, guys, you guys read an article on corticosteroids. Where do corticosteroids come from? They come from cortisol. Okay, actually, they're all derived from cortisol, and there are some good things that come along with it. It helps regulate your immune system. So let's say you have really bad asthma, take a corticosteroid. Let's say you have to get a transplant for a new organ because something's wrong with the organ you have. Take a derivative of cortisol. That will help slow the immune system down so you can have an overwhelming immune response. However, the bad effect is you might get a little big, a little chunky when you're on corticosteroids. Okay. It also too stimulates the production. ACTH also stimulates the production and release of weak androgens from the zona reticularis. Okay. And these are variations of testosterone and estrogen. They're derivatives of it. They're not exact. It's not exactly estrogen, testosterone. It's a derivative of it. Okay. So the GFR, go find Rex, glomerulosa, fasciculata reticularis, aldosterone, cortisol, sex hormones. Okay. That's how I remember it. GFR, go find Rex, glomerulosa, fasciculata reticularis, aldosterone, cortisol, sex hormones. Okay, and also too, part of ACTH, this is kind of a fun fact. This might be a little fun bonus question on your exam. The first portion of ACTH actually can be cleaved off as well, and when that happens, it makes a hormone called alpha melanocyte stimulating hormone, or MSH, which darkens the skin. So when somebody has a problem with their adrenal gland, what happens is the pituitary gland will start stimulating the release of ACTH in response. Hey, we need some cortisol. We need some cortisol. And what will happen is the skin will get darker. So if somebody has Addison's disease, let's say, you'll notice their skin's like. If you ever see a picture of John F. Kennedy, our former president, he had Addison's disease. And you notice his skin's really, really bronze and really, really dark. It's because ACTH is releasing like crazy from the pituitary gland in response to him not having enough cortisol in his body. So but that's a part of it. So this alpha melanocyte stimulating hormone is a part of ACTH that you can cut off. Okay, it's a great picture. It's a beautiful picture of the adrenal glands, guys. So you see here outside the capsule, then you have the GFR, and you see what's the vast majority of the adrenal cortex? That would be the zona fasciculata. So the most important thing the adrenal cortex is going to make is cortisol. Okay, but it also does make aldosterone. Also does make some weak sex hormones as well. Okay, feedback loops in the anterior pituitary. So 5 of the 6 hormone feedback loops will be governed by negative feedback loops. So guys, the vast majority of the feedback loops we talk about in A and P are going to be negative feedback loops. Okay. However, so once the hormones are released by the anterior pituitary, the hormones from the anterior pituitary and their products they produce, and by their effects, either T3, IGF, cortisol, they will all go back to the hypothalamus and the anterior pituitary and shut off future secretion of releasing hormones. Okay. So what happens is this. So let's say, for example, we have thyroid hormone pathway. TRH stimulates TSH, which then stimulates T3 and T4. Once you release T3 and T4, T3 and T4 will go to their targets, absolutely. But they also go back to hypothalamus and they go back to the anterior pituitary and they shut off any more release of TRH or TSH. They shut it off automatically. So we don't get too much of it. So that's negative feedback. So the products we produce in the end will all go back to hypothalamus and the anterior pituitary and shut off for future secretion. Okay, the only exception is prolactin. And prolactin, again, is governed by a positive feedback loop. It's one of the two hormones you need to know that are governed by positive feedback loops. Prolactin's one, the other one's oxytocin. Okay, so what dopamine stops blocking prolactin release, prolactin will go back and stimulate the release of more prolactin. So we just keep on going. So once prolactin's released from the anterior pituitary, prolactin will go to the breast tissue, certainly, and stimulate the production of milk. However, it also goes back to the anterior pituitary and says, hey, we need more prolactin. And this goes back around the loop until eventually there's a signal to shut that whole cycle off. Think of it like a water hose, guys. And like once you cut the water hose on, does it ever cut off on its own? No, you have to go back and physically cut off the water hose yourself. Okay, this is a picture of a beautiful picture here of the hypothalamus pituitary adrenal axis, and you guys see here we have CRH stimulating the production of ACTH, stimulating the production of cortisol, and what does cortisol do? It goes back and shuts off the release of ACTH, and also shuts off the release of CRH, so we don't get too much of this. Okay, and if we break this at any point, there could be lots of diseases that can happen. So if we get too much ACTH secreting, we're going to get Cushing's disease. If we get too little ACTH secreted, we're going to get possibly Addison's disease. Here's another one. Here's the hypothalamus pituitary gonadal axis. So if you see here, G and RH stimulates the production of LH and FSH. Okay, then those stimulate the production of testosterone, estrogen, and progesterone. When those levels get high, testosterone in men will go shut off the pituitary from releasing any more LH and shut off the hypothalamus from releasing any more G and RH. Same with estrogen and progesterone in women. It's the same concept, guys. So you see it goes back and shuts it off. Then this is negative feedback. Okay, then also we have the hypothalamus pituitary thyroid axis, and same concept. TRH stimulates TSH, stimulates release of T3 and T4 from the thyroid. Then T3 and T4 go back and shut off the pituitary and the hypothalamus. So we don't get too much T3 and T4 hanging around. Okay, and here's the prolactin axis. You guys, it's really weird. See how much more involved it is? This is because it's positive feedback. And you see here, prolactin goes back and stimulates more prolactin release. Okay, so that's your anterior pituitary. Now let's talk real quick about your posterior pituitary. Your lecture, the big lecture you guys got before spring break didn't have everything I wanted on it. So the posterior pituitary is called the neurohypophysis. So neuro means nervous. This comes from nervous tissue. So the anterior pituitary comes from oral mucosa, while the posterior pituitary comes from nervous tissue. Okay, it is directly connected to the hypothalamus via what's called the infundibulum. Okay, that connects the posterior pituitary to the hypothalamus. Okay, now again, this will be on your test. I can promise you. I love this question. This portion of the pituitary does not make its own hormones. It does not make its own hormones. It does not make its own hormones. The posterior pituitary does not make its own hormone, guys. Please know that. The hypothalamus makes it and stores it in the posterior pituitary in its axon. So if you guys see here in the picture to the right, of the paraventricular nucleus, you have the supraoptic nucleus, and this nucleus will then shoot their axons down to the posterior pituitary. You see here, nothing is made here. Okay. Then now the two hormones that the posterior pituitary releases are stored in here, but they're not made here. They're just a warehouse, basically. They're a warehouse for these hormones. Okay, then when they're stimulated, the axons of the posterior pituitary are stimulated to release their hormones instead. Okay, the hypothalamus makes oxytocin, antidiuretic hormone. Antidiuretic hormone stimulates the retaining of more water in the kidney tubules to lower blood concentration of solutes. So let's say your sodium levels get too high. Let's say you went for a run, you went running, and you started sweating. You sweat water out, obviously. So what will happen is your blood concentration of sodium and potassium will then go up. This will be in the hypothalamus, actually, and this will stimulate the release of antidiuretic hormone. Okay, and what the antidiuretic hormone do is it goes to the kidney tubules and causes reabsorption of water. We just reabsorb water like crazy. We just keep reabsorbing water. Okay, and that's going to lower the concentration. So if you have more water, you can dissolve more solutes. So that's going to decrease the concentration of sodium and potassium and other solutes that are in the blood. Okay, then lastly, we have oxytocin, which stimulates uterine contractions during childbirth, the ejection of milk from the breast, and is stimulating during cuddling and bonding. This is governed by a positive feedback loop. Okay, so a positive feedback loop. So the two positive feedback loops you need to know: oxytocin, prolactin. If you got those, you're golden. And this is what the posterior pituitary looks like. And you guys see this is beautiful, beautiful image here. Supraoptic nucleus, paraventricular nucleus here, and they're bringing their axons down to the posterior pituitary, and then all the ADH and the oxytocin will be stored in the posterior pituitary in those axon terminals you guys see here. So, hope this helps you guys in your studying. If you need anything, please reach out, let me know, and I will talk to you guys soon.